Hello friends. In today's video lecture we will study another important topic which is related to the thermodynamics of open system. Before that, again I will revise. So far about thermodynamics we study three important equations. One is Helmholtz free energy equation, second one is Gibbs free energy equation, and third one is a Gibbs-Helmholtz equation. Here I request all students to write all three equations in your notebook. In physical chemistry, equation as well as numericals are very important, and therefore you should write all these in your notebook. Whatever the topic we covered in whole every day, you should write on the same day so that you can understand physical chemistry in good manner. So that will be the good practice actually. So today we will discuss partial molar properties. The word partial, that means what actually? There is some properties which are used to study the thermodynamics. What do you mean by molar? That is actually, this is the different word than, you know the word molarity, number of moles present in 1 liter of solution, that is called as molarity. And what is molality? Number of moles of solute dissolved in 1 kg of solvent, that is called as molality. So here the properties of system can be divided into two types. The properties of the system can be divided into two types. What are the two types? So basically we have two types of property in thermodynamics. One is called as an extensive property, another is a intensive property. So here in extensive property, those property which depends upon the amount of substance, those physical property or those thermodynamics property which depends on amount of substance, that properties are related to extensive property. While those property which are not depends on amount of substance, that is called as a intensive property. You can see here is the definition. The extensive property is the property which depends on the total amount of substance or the total amount of different constituents of the system. Whatever the constituents which are present in the given system, if any property which depends on that amount of substance, that is called as the extensive property. For example, mass, volume, energy, entropy, free energy, all these are called as extensive property. Everybody understood what are extensive properties? Remember, this is very important question for examination. On the other hand, an intensive property which does not depends on the total mass or total volume of the different constituents or substance. For example, pressure, temperature, density, refractive index, these are intensive property. Let me take one example for our understanding. Suppose I will take a property that is an intensive property. For example, pressure. If I consider pressure inside the room at normal temperature, let's say it is 1 bar, and when you go outside the room, that pressure is also remains same. That means pressure become a intensive property. Similarly, if you consider at room, inside the room, if temperature, let's say that it will be 25 degree, outside temperature may be 26, 27, but it doesn't depends upon amount. If you change the amount, temperature doesn't change. For example, 1 ml of water having density 1, and if we have 1 ton of water also having same density, there is no change. So in simply, there are two types of property which depends on, or which can be categorized on the basis of quantity of substance or the amount of the substance. Now, total mass of the system is a extensive property, but mass per mole is an intensive property. For example, if you consider a universe having a x amount of mass, so that is remains constant, it is not going to change. But mass per mole, for example, I have 1 mole of hydrogen gas having mass, suppose let's say 1. If I take mass per 2 mole of hydrogen, that will be different, right? Mass of 2 mole of hydrogen is different, mass of 1 mole of hydrogen is different. So now it become a intensive property. Volume per mole, energy per mole are also intensive property. That means mass per mole, as I said initially also, mass, volume, energy, these are called as a extensive property. That means they depends on amount. For example, when I eat something, I will get X amount of energy, and after certain time energy if I lost, then it become a X2. So there will be change in energy, so energy become a extensive property. Similarly volume also, but mass per mole, volume per mole, energy per mole, these are intensive property. So for 1 mole of water, whatever the mass, that will remain same. 1 mole of volume of water, that will be also remains same. So mass per mole, volume per mole, energy per mole are called intensive property. Everybody understood? Now next, the total mass of closed and isolated system always constant. Whether the system is closed or open or isolated, mass remains constant. Okay. The change in any thermodynamic property is due to change in the state of the system. The change in any thermodynamic property which is due to change in state of the system and not due to addition or removal of matter. Whatever the change which we saw in a system or a state of the system which is not due to addition or removal of matter, okay, but for open system, mass and composition of constant particle present in the system can also vary. What is open systems? Where both mass and energy can be changed, can be varied. So you have to consider this thing in your mind while understanding the partial molar property, because we want to study here thermodynamics of open systems. Open system means what? Those systems where what happen, energy and mass that are going to change. So these are the things you have to keep in mind while understanding the thermodynamics. Now G.N. Lewis introduced a new concept that is called as partial molar properties for studying open system. Which properties? Partial molar properties. To understand the partial molar properties of a open system, you have to consider that an open system composed of I constituents. That means I have open system, let's say a glass of water, which is open system. Let N1, N2, N3 up to Ni be the number of moles of constituent. That means for open system I have a I constituents, right? And that I constituent is present in the ratio of 1, N1, N2, N3 and up to Ni be the number of moles of that 1, 2, 3 I component which are present in the system. Let X be the thermodynamic extensive property of the system which are selected for study. X be the capital X be the thermodynamic extensive property. Okay, that may be like mass, volume, whatever, that will be the your extensive property. Its value is determined by the state of the system, temperature and pressure, and the amount of various constant present in the system. It means the property X is a function of temperature, pressure and amount of various constant present in the system. Obviously, suppose I have X as a thermodynamic extensive properties of the system, right, which depends on some various parameter like temperature, pressure and amount of constituent particle present in it at that time. I will define the system X. X is a function of all these three parameter like what, pressure, temperature and number of constituent present in the system, n1, n2, n3 up to ni. That now become a, that means whatever I told, all these things can be written in the equation form. What is X is here? X is a thermodynamic extensive property. X is equal to, okay, it is the function of pressure, temperature and number of moles of various constant particle present in the system. Then change in property dx due to change in pressure, temperature and amount of various constant is given by equation. Dx is equal to, in bracket, d by x upon d by p, bracket, complete at constant temperature and pressure, dp. Okay, again I will tell you here, the change in property dx is due to what? Small change in pressure, temperature and various amount of constant particle in a given system. So this can be written in the form of what? Dx is equal to, in bracket, d by x upon d by p, bracket, complete dp at the constant temperature and number of various constant particle, plus d by x upon d by t at constant dt at multiplied by dt at a constant pressure and number of constant particles, plus d by x upon d by n, in bracket dn, bracket complete, dn upon at constant pressure, temperature and now here other moles remains constant. If you consider for 1 mole, then n2, n3, n4, ni, that is remains constant. So this can be written up to ni times, plus d by x upon d by n2. Now here second mole you have considered dn2 at constant pressure, temperature, d1, d3 up to ni, plus dot 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 plus d by x upon d by n I, in bracket dn, bracket complete dni at constant pressure, temperature up to n1 minus I minus 1 x. Now the quantity d by x upon d by n1 at pressure, at constant pressure, temperature and other constant particles is called as partial mobile properties of first constituent, and it is denoted as x1 bar. Same things can be written for second mole constant particle, d by x upon d by n2 at constant pressure, temperature, n1, n3 up to ni. This is called as partial molar properties of second constant particles, denoted as x bar 2. For I, you can written d by x upon d by ni pt at constant pressure and temperature, n1, n2, that is also constant, n in bracket 1 I minus 1. So that ith constant particle is denoted by xi bar. So thus xi bar is equal to, sorry, thus x1 bar is equal to d by x upon d by n1 at constant pressure, temperature, n2 up to ni, that is equation number 53. For second, x2 bar is equal to d by x upon d by n2 p, pressure, temperature, n1, n3 up to ni. For ith, you can write d by x upon d by ni is equal to pt, n1, n2, ni minus 1. So substituting in equation 52 gives dx is equal to d by x upon d by p at bracket complete dp at constant pressure and number of constant particles. Similarly for temperature and other number of moles. So this equation 56 is called as partial molar properties, total partial molar properties of a X system. At constant pressure and temperature, the first two terms on RHS remains 0. So dx is equal to x1 bar dn1 plus x2 bar dn2 plus dot 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 plus xi bar dni. The equation number 53 can be concluded that partial molar property signifies the change in extensive property. Okay, everybody understood? So X become a extensive properties of the system with the change in number of moles of first constituent of the system. Right? The partial molar property is the change in property of X of system at constant pressure and temperature. When one mole of particular constant is added in such a large quantity of system so that added mole does not affect the composition of the system. Okay, that means in short what happen if you add 1 glass of water sea in a ocean, there is no change in the volume of that water because that addition is very negligible. Similar thing is here. If you consider for the partial molar properties of one component with respect to other, that will be very negligible. So the partial molar property is the change in properties of X of system at constant pressure and temperature when 1 mole of constant particles is added to such a large extent so that added mole does not affect the composition of systems. Okay, so next time we will study the partial molar volume. Okay.